All right, here we are. Last question of practice test number 3. And it's a pretty cool question. And it says, if an object is projected upward with an initial velocity of 48 feet per second from a height h of 64 feet, its height t seconds after it is projected is defined by the equation f of t equals negative 16t squared plus 48t plus 64. All right, so really what this is saying is, and it sounds a lot more difficult than it is, but what we have here is, let's just say that this is the ground, and let's say that we have somebody standing on a building, and so here this person is standing on a building, and this building is 64 feet high. They're going to toss some object in the air from the top of this building, so let's say a baseball. So they toss this baseball up. This formula here, this function, tells us how long it's going to take from, in t seconds, from when the person throws this ball up in the air with a velocity of 48 feet per second, how long it's going to take to hit the ground. All right, so what we're going to do is find t, which is the time it takes to actually accomplish this. So we have f of t equals negative 16t squared plus 48t plus 64. So this f of t is the output. This tells you how far off the ground your object is based on your input of t. So if you want to know how far off the ground this object is after 1 second, plug in 1 to everywhere you see a t, and the output will be how high off the ground that object is. If you want to know how high the object is off the ground after 2 seconds, plug in 2 where you see a t, and the number you get out will be how high off the ground this object is. In this case, I said a baseball. But what we're going to do is we're going to do it backwards, and we're going to first say that, well, we want the output to equal 0 because we want to know how many seconds. So we're going to solve for t. We're going to actually solve for t. How many seconds after it is projected will it hit the ground? Well, remember, the output, your f of t, is the distance above the ground. So if we're talking about an object hitting the ground, we're talking about an object that is 0 feet off the ground, right? Because it's laying on the ground. So what we can do is we can rewrite our function to say, instead of equaling f of t, which is the general form, now we're saying, no, we want the object to equal, we want 0. We want to know what t value gives us the time when this object is hitting the ground, or 0 feet above the ground. Well, now we have ourselves a quadratic equation, don't we? Quadratic equation. 3 terms set equal to 0, and we know what to do with this, don't we? Let's go ahead and ask ourselves those 3 questions. Number 1, is there a GCF? And it looks like in this case there is. Not only can we factor out a 16 from each of these, but let's go ahead and factor out a negative 16, because you'll recall that we can't factor when the leading term, that squared term, is negative. So if we just took out a 16, we'd be left with negative t squared plus, 3 plus or minus 64, right? So let's go ahead and factor out a negative 16. And when we do that, now we're left with t squared minus, and 48 divided by 16 gives us 3, t. And 64 divided by 16 is going to give us a negative 4. All right, so we factored out a negative 16, and now that leaves us a nice trinomial with relatively simple numbers that we know is going to factor into 2 binomials. We're dealing with t, so let's go ahead and break up that t. And now we want factors of 4 that subtract to give us negative 3. Well, what are the factors of 4? 1 and 4, 2 and 2. So of these factors, which ones can we subtract to get a negative 3? We can't subtract 2 and 2 to get a negative 3, but we can subtract a 1 and a 4 to get a negative 3. So if we had a positive 1 and a minus 4, 1 minus 4 gives us negative 3, and 1 times -4 gives us -4. So there we have it. All right, and we know what to do from here. Now that we've factored our polynomial, we're going to go ahead and, let me just rewrite it over here. Let's set each of these factors equal to 0 independently, which is what we've been doing. So we have -16 equals 0, we have t plus 1 equals 0, and we have t minus 4 equals 0. All right, -16 equals 0. Is that a true statement? Nope. So that factor completely disappears. It goes away. You can get rid of it because it results in a false answer. So that goes away. Let's solve for t here. So we have t equals -1. Oops. T equals -1. Here we have add 4 to both sides. So t equals 4. And we know that t represents time, right? And can time be negative? Can you have a negative time? Well, no. If you figured out negative time, you would be able to figure out how to time travel backwards in time, and you would be a pretty wealthy person probably. But right now, we can't travel backwards, so we're going to drop the -1 as a potential answer because time only moves in one direction. It only moves forward. It's only positive. So we get rid of that negative answer, and we're only left with the positive answer of t equals 4. And so what this is telling us is that after 4 seconds, so if somebody throws a baseball up in the air, after 4 seconds is when it's going to hit the ground, assuming these conditions are true, assuming that the initial velocity was 48 feet per second and that we were throwing this baseball from a height of 64 feet. All right, so t equals 4, and so you can just say how many seconds after it is projected will it hit the ground? You can just say 4 seconds. All right, and there you have it. Number 61, not too bad. And this is pretty cool. So if you've taken physics, this might look familiar to you, or if you are planning on taking physics, then you're definitely going to do a lot of problems dealing with this. And this equation is derived from the force of gravity on Earth and some pretty cool other things. But this is just a general form for this specific scenario here. All right, well, I hope this was helpful. I'll go ahead and wrap things up in a closing video like I normally do, but otherwise, best of luck to you on your test. As always, if you need anything, please don't hesitate to email me, and make sure that you're doing your homework, you're going to the lectures, you are doing this practice test, and utilizing the resources like the PASS lab on the Gardens campus, or the math lab on any of the other campuses. All right, so for now, this is Joe Brownlee with Palm Beach State College. I'll see you around.